Good morning, students. In the last video, that is my arithmetic progression, it is a coordinate geometry part 3. I have brought you the problems of distance form. Different problems you have solved, and you know that we came to know that when a point is on the x-axis, its y coordinate is 0. That means when the point is on the x-axis, we can say it is x 0, and if the point is on the y-axis, we can say 0 y. And based on such statements also, the problems were there and we have solved it. And apart from that, we have seen the problems of equilateral triangle, isosceles triangle, right angled isosceles triangle, points are collinear, all those we have completed. You have seen the points are on the x-axis, find the value of x, the point is on the y-axis, find the value of y, that also we have completed. Now, we are going to the problems of quadrilaterals. We are going to the problems of quadrilaterals, and I will give you the 4 coordinates. When there were 3 coordinates, we have solved the problems of triangle. Now I am giving you the 4 coordinates, and using those 4 coordinates, you should tell what type of quadrilateral you are going to get. That means it may be a parallelogram, it may be a rectangle, it may be a square, it may be a rhombus. How to differentiate? Suppose, for example, I have given you, show that the points A 4 5, B 7 6, C 4 3, and D 1 2. Taken in order, form a parallelogram. We have to show that these 4 coordinates forming a parallelogram. How to do it? Now, before we solve this problem, let us understand first. See, this is a parallelogram. Here is a rectangle. This is a square, and here is a rhombus. Now, the 4 coordinates are given. A is given, B is given, C is given, D is given. Using the distance formula, say you have found AB, you have found BC, you have found CD, you have found it, all the 4 sides you have found. Say for example, you got this as root 43, this as root 23, this as root 43, this as root 23. Example I am telling you, it's only example. What we got? Opposite sides are equal, opposite sides are also equal. It can be a parallelogram or it can be a rectangle also. In parallelogram also opposite sides are equal, rectangles also opposite sides are equal. Then how to differentiate? Between a parallelogram and rectangle? Here also say using the 4 coordinates, say P, Q, R, S. You got this as root 51, root 17, say root 51, root 17. Here also opposite sides are equal, this is also equal, these two are equal. Then how to differentiate whether it is a parallelogram and rectangle? For that, you have to find the diagonals. Where the difference lies, in the rectangle, diagonals are equal, whereas in the parallelogram, diagonals are unequal. See, this is the longer diagonal, this is the shorter diagonal. So I will write here, opposite sides equal, diagonals unequal. That is, then it is a parallelogram. If you come to rectangle, say I can say say opposite sides are equal. Diagonals are also equal. Here diagonals are unequal, diagonals are equal. Therefore, or you can say then it is a rectangle. If you come to the square, all sides are equal. See, only opposite sides are equal. Here all sides are equal. Diagonals are also equal. Then it is a square. At last I am coming to what? The rhombus. All sides are equal. Diagonals unequal. See, this is the shorter diagonal, this is the longer diagonal. Diagonals are unequal. Then it is a rhombus. In this way you can differentiate. Note all these things which will be helpful for you. Now I will start this. Let me take a small rough figure. Call it as ABCD. Let me mark up. See, taken in order means you can't say A, B, C, D. Either in the clockwise direction or in the anti-clockwise direction. In a particular order it should go. See, A, if you start from here, A, B, C, D. Or A, B, C, D. A, B, C, D. Or A, B, C, D. Either clockwise or anti-clockwise. Come on. I will write here 7, 6, 4, 3. Oh, sorry. First 4, 5 is there. Sorry. It is 4, 5. Then it is 7, 6, 4, 3, 1, 2. We'll start one by one. We have to apply distance formula for 6 different times. 1, 2, 3, 4, 5, 6. 6 times it has to be applied. Come on, we start one by one. Yes. Let me find the length of AB first. AB is under that. Come on. Now it's simple. 4 minus 7 the whole square. 4 minus 7 the whole square plus 5 minus 6 the whole square. 5 minus 6 the whole square. Under that. Minus 3 square 9. Minus 1 square 1. Answer is square root of 10. We got the first answer as square root of 10 units. Okay? We got the length of AB. Come on, we start the length of BC. BC is equal to under root. Come on, BC. 7 minus 4 the whole square plus 6 minus 3 the whole square. 6 minus 3 the whole square. 7 minus 4 3. 3 square is 9 plus 6 minus 3. 3 square is 9. Answer is square root of 18. Square root of 18 units. We got 2 lengths. Let me go for the third. I will go for C. C is equals to under root. CD. Anywhere. This minus this or this minus this. Anyway. 4 minus 1 the whole square. 4 minus 1 the whole square plus 3 minus 2 the whole square. 3 minus 2 the whole square, which is equals to 4 minus 1, 3 square, 9 plus it is 1 square is 1. Answer answers. Root 10. Root 10 units. Root 10 units. Let me go for, I will make it a U. Root 18. Root 18. Come on. Let me go for, see what? Now I go for 80. 80 is equals to under 80. This minus this or this minus it. Anyway, 1 minus 4 the whole square. 1 minus 4 the whole square plus 2 minus 5 the whole square. 2 minus 5 the whole square. Come on, and minus 3. Minus 3. Minus 3 square. 9. 2 minus 5. Minus 3. Minus 3 square is 9. Answer is square root of 18 units. Square root of 18 units. My dear children, what we learned? See, opposite sides. AB, CD. AB and CD are opposite sides. Both are root 10. BC and AD. BC and AD are the opposite side. They are also equals to each other. Okay, now I have to check the diagonals. I have to check the diagonals now. Let me find the length of AC using these two coordinates. Come on. AC is equals to under root 4 minus 4 the whole square plus 5 minus 3 the whole square. 4 minus 4 the whole square plus 5 minus 3 the whole square. It is 0 square. 0 plus. It is 2 square is 4. Answer is square root of 4. Nothing but 2 units. 2 units. AC. Now I have to find the length of BD using these two coordinates. Come on. BD is equal to under root 7 minus 1 the whole square plus 6 minus 2 the whole square. 6 minus 2 the whole square. Nothing but 6 square 36. 4 square 16. Answer is square root of 52. Anyone? Yes, 52 units. See now? Opposite sides are equal. Diagonals are unequal. I can wind up my answer here. Opposite sides are equal and diagonals are unequal. Diagonals are unequal. Therefore, ABCD is a parallelogram. My dear children, this will be a definite 4 marks question in the examination. 4 marks question in the examination. Complete 4 marks you can get very easily if you slowly and systematically solve it. Note it down. Go for one more. Okay, students, this is a problem which is on square. 4 vertices are given to you and they ask you when they are taken in order, they are the vertices of a square. You know the condition for square? All the 4 sides must be equal. Diagonals must also be equal. Then we can say it is a square. And solve this problem. Then I will give you 2 problems as a homework. One for the pair, one for the rectangle, and one for the rhombus. It will be a homework. Come on, let me. Okay, let me draw a small figure. Let me call it as P, Q, R. Yes, taken in order. This is 1 and 7. This is 4 and 2. Minus 1 and minus 1. Minus 4 and 7. Sorry, minus 4 and 4. My dear children, those who have understood the concept, they can pause the video, do it yourself. Come on, I will also start. Let me start with PQ is equals to under root 1 minus 4 the whole square. 1 minus 4 7 minus 2 the whole square. 7 minus 2 the whole square. Under root. Minus 3. Minus 3 square is 9. It is 5. 5 square is 25. Answer is square root of 34 units. You got the first length pick. Let me go for QR. QR is equals to under root. Come on, QR. 4 minus of minus 1. 4 minus of minus 1 the whole square plus 2 minus of minus 1 the whole square. 1 minus from the formula, 1 minus from the coordinate. 2 minus of minus 1 the whole square, which is equals to under root. Minus of minus is plus. 4 plus 1 the square. Minus of minus is plus. 2 plus 1 the whole square. Under root. 5 square 25. 3 square 9. Answer is square root of 34 units. Square root of 34 units. We got length of two sides. Come on. We'll go for RS. RS is under root. Okay. Minus 1 minus of minus 4. Minus 1 minus of minus 4 the whole square plus minus 1 minus of minus 4 the whole square minus 1 minus 4 the whole square minus 1 minus 4 the whole square equals under root. Minus of minus is plus. Minus 1 plus 4 the whole square. Both are minus. Minus 5 the whole square. Under root. Minus 4, minus 1 plus 4. Minus 1 plus 4 gives you 3. 3 square, 9. Minus 5 square, 25. Answer is square root of 34 units. You got the thirds. Root 34, root 34, root 34. Let me find the length of last. PS. PS is equal to under root. Anyway, minus 4 minus 1 the whole square. Minus 4 minus 1 the whole square plus 4 minus 7 the whole square. 4 minus 7 the whole square equals to under root. Minus 4 minus 1 minus 5 minus 5 square 25 plus 4 minus 7 minus 3 minus 3 square is 9. Answer is square root of 34 units. All the four sides are equal to each other. Root 34, root 34, root 34, root 34. Two diagonals. We have to find that. Don't think that diagonal will also be root 34. No. Because you know that the diagonal is definitely greater than the size hypotenuse of a triangle. So it is definitely not root 34. Any different number, but both numbers must be same. This and this must be same, but not root 34. Okay, let me go for PR. PR is equals to under root. 1 minus of minus 1. 1 minus of minus 1 the whole square plus 7 minus of minus 1. 7 minus of minus 1 the whole square. Under root. 1 plus 1 square plus 7 plus 1 square equals to under root. 1 plus 1 2 square is 4. 7 plus 1 8 square is 64. Answer is square root of 68 units. I should find the last length QS. It must be also root 68 only. Come on. QS is equals to under root QS. 4 minus of minus 4 the whole square. 4 minus of minus 4 the whole square plus 2 minus Right here. Therefore, QS is equal to square root of 68 units. I can write at the end. All sides are equal. And diagonals are also equal. Therefore, PQRS is a square. That is the end of the problem. This is the last problem of distance formula. Again, I can say an important problem from the examination point of view. Let us understand it first. What they say? Find the relation between. They did not ask you to find the value of x, nor they asked you to find the value of y, but they asked you the relation of x and y, such that the point xy is equidistant. Point we know that, right, children? This is the problem of equidistant. Just I will mark it. It is equidistant from the two points. Such problem was solved already. I will just draw the small figure and I will explain you. What they say, there are 2 points, say A, 2, 5, and another point B, minus 3, 7. And there is a point here, I can say P, whose coordinates are x and y. And this point is equidistant from these two. This is already we have solved. But what is the speciality? Son, the problem what I have solved earlier, they have told this point is on the x-axis. The point is on the x-axis. That means y coordinate is 0. See, earlier, just to refer my previous video, there I have told find the point is on x-axis. The point on the x-axis, just to recall, the point on the x-axis is equidistant from the point on the x-axis, means y coordinate is 0. In this case, you can find the value of x. You can find the value because x is the only unknown here. You can find the value of x. Or in my previous video, I have given you the homework. The point is on the y-axis. The point is on the y-axis. Means when the point is on the y-axis, x coordinate is 0, 0, y. 0, y. How many unknowns are there? Only one unknown is there. So y value also can be found. Okay. But now they say the coordinate is neither on the x-axis nor on the y-axis. It is in the plane. The coordinates are x, y. How many unknowns are there? 2 unknowns are there. You can't find the value of x and y because 2 unknowns. But you can find the relation between x and y, like x is equal to 2y, x plus 2y is equal to 0. Such equations we are getting, but not the value of x and y. Come on, method is same. Method is same. Only I want to show you when both unknowns are there, its value cannot be found. If it is on the x-axis, x0. If it is on the y-axis, 0y, value can be found? Not in this case. Come on, let us start. As usual, no change in the method. I will find the length of AP. AP is equal to under root. AP is equal to under root. Come on. X minus 2 the whole square. X minus 2 the whole square plus y minus 5 the whole. Y minus 5 the whole square. Know the formula? A minus b the whole square because 1 is unknown here. Okay? Which is equal to under root x square minus 2ab, 2 into a into b, 2 into x into 2 plus b square is 2 square plus y minus 5 a square minus 2ab, a square minus 2 into a into b, 2 into a into b plus b square plus b square, which is equals to under root. Come on, x square minus 4x plus 4 plus y square minus 10y plus 20 This is the length of AP. I will call this as equation number 1. Okay. Let me go for length of BP. BP is equal to, come on, under root x minus of minus 3. X minus of minus 3 the whole square plus y minus 7 the whole square. Y minus 7 the whole square, which is equal to under root. It is minus of minus is plus. X plus 3 the whole square plus y minus 7 the whole square. Now I will expand it, which is equal to under root a plus b the whole square. A square plus 2ab plus b square. A square plus 2ab plus b square plus a minus b the whole square. A square minus 2ab plus b square, which is equal to under root x square plus multiply 6x plus 9 plus y square multiply minus 14y plus 7 square is 49. I can call this as equation number 2. Then given that they are equidistant, the lengths are equal, I can say since AP is equals to BP, I can say under root x square minus 4x plus 4, I can plus 4, no problem, plus y square minus 10y plus 25 is equals to under root x square plus 6x plus 9 plus y square minus 14y plus 49. When you square them, what happens? Both square roots are getting cancelled. When you square them, both square roots are getting cancelled, and I can write x square minus 4x. I will add these two, that becomes 29 plus 29 plus y square minus 10y is equals to here x square plus 6x, add these two, that gives you 58, yes, plus 58 plus y square minus 14y minus 14. My dear children, what are the things are getting cancelled? I will just cancel with a different color. Come on. This x square gets cancelled. Because when you bring it to the LHS, it will become minus x square. So cancel. Y square cancel. Don't get confused. Sir, both are positive. How you have cancelled? No. This is in the LHS. This is in the RHS. Equal to is that when you bring it to the LHS, it becomes minus y square and then get cancelled. Okay? I will write the remaining things. Let me write. Minus 4x plus 29 minus 10y. I will bring these terms to LHS only. Minus 6x LHS minus 58 plus 14y is equals to 0. Come on, simplify. There are two 6x terms minus x. There are two y terms plus 14y minus 10y gives you plus 4y. Then this is 29 and this is minus 58. It is 58 minus 29 gives you 29. Bigger number sign is negative, is equal to 0. I can write this as minus 10x plus 4y is equals to 29. This is the relation between x and y. I have told you, you are not getting the value of x and y, but instead you are getting a relation. That is minus 10x plus 4y is equals to 29. This is the end of the solution. My dear children, these are some of the problems what we have discussed in the distance formula. I hope every problem is covered, but I will give you 4 problems as a homework. I have not solved the problem of rhombus, I have not solved the problem of rectangle. So those problems which can be practiced at your end, it's very much essential also. I will give it, and that will be the end of your distance formula. These are the 4 problems I have given you as a homework. The first one is find the relation between x and y. As I told you, when they ask you relation between x and y, neither you can find the value of x nor you can find the value of y. Instead, you are getting a relation between x and y. Keep in mind. Okay. Then they told these are the vertices of a square. Already we have solved. All the 4 sides must be equal. Diagonals must be equal. Then you can say it is a square. Show that it is a rhombus. Rhombus. What is the condition for rhombus? All the 4 sides must be equal and the diagonals must be unequal. And you can say it is a rhombus. And finally, there is a problem of a rectangle. Opposite sides are equal. These two are equal. These two are equal. And the diagonals both must be equals to each other. With that, you can say it is a rectangle. My dear children, this is all about your first part of the chapter distance. And when we meet in the next class, I will teach you the second part of this chapter, that is section 4. Now you can very conveniently, very comfortably complete the exercise. First exercise of the chapter, coordinate geometry, and I am very sure each and every problem you can solve it very easily. Sometimes they may ask you, apart from this, sometimes they may ask you, name the triangle. They may not ask you show that it is a right triangle, isosceles triangle. They may ask you name the triangle. It can be a scalene triangle, it can be isosceles, it can be equilateral. Accordingly, you have to first find all the 3 sides, and whichever is applicable for that, if all 3 are equal, equilateral, and accordingly you can write it. Here also same thing. They may ask you name the quadrilateral. Name the, instead of asking show that it is a rhombus, they may ask you name the quadrilateral. Find all the 4 sides, both the diagonals, check how they are related, and accordingly you can give the name of that quadrilateral. That's all, students, about the first part, distance formula. Okay, we'll meet in the next video. Till then, goodbye.